Okay, in this problem, we're going to look at expected value, and this would be an example of a legal case. So maybe you're a lawyer and you're trying to advise your client. So say if they settle out of court, it's going to cost them $300,000 to do so. But if they go to trial, there's a possibility that it comes back guilty, which in case they lose $800,000. And then there's a possibility that it comes back not guilty, and they lose nothing. Obviously, they're going to lose the legal fees to you regardless of whether they settle or not. So, so maybe it's a little simplified. Maybe there'd be more legal costs, I guess, if you go to court. But pretend that the legal fees aren't part of this. It's just what they're going to end up paying for court costs as far as if they settle or if they lose or if they win and they're not guilty. So I want you to go ahead and find the expected value, which again is probability value, probability value. Something's usually negative in there because you usually have some positive money and some negative money. And go ahead and make the chart, see if you can figure this out, and then we'll talk about it together. Okay, so let's look at this a little bit. If you settle, you're at $300,000. So really, we have to look at kind of the trial situation and compare that to that $300,000. So you're going to have probabilities. And so in this case, if there's not guilty, you're going to have 80% probability. So obviously, if you're guilty, then that's the rest of that 100%. So guilty would have to be 20% because these two together have to add up to 100%. If you're found guilty, you're going to lose $800,000. And I usually like to make that negative, but when you interpret it, it depends on how the problem's worded, what you do with that. And if you're found not guilty, which you have an 80% chance of, you're not going to have to pay any fines, okay? And again, the settling is a whole different thing. I can make a probability value chart for that, but there's only one outcome, is there's a 100% probability that you settle, and if you settle, you lose $300,000. So there's not really interesting math because there's not another option there. So in my chart, probability times value, so I have 80% probability with a value. And again, this is kind of like when we did like a weighted mean, like when we did credit card and we found the average daily balance on a credit card. It's kind of the same idea. So we have 80% times 0, and then we have 20% times a loss of $800,000, okay? So obviously this first part is 0, and the second part would be what? Negative $160,000, okay? So expected value is kind of like your average, okay? So, and again, depending on how the expected value is worded, if you are the client, I guess here, this means you would lose, on average, you're going to lose $160,000 if you go to court. So if you went to court millions and billions of times, sometimes you would win at court, sometimes you would lose at court. On average, you would lose $160,000 if you had a similar rates and so forth. So then the question is, if that's your expected value, should you settle? Okay, well, if you settle, you're going to lose $300,000. If you go to court, it's kind of saying on average, basically. So on average, you would lose $160,000. So I would say no. The expected value is telling you that it would be better to go to court than to settle. All right, so we will do another example here in just a second. Okay, so this next scenario we're going to look at is trip insurance. So say that for $50 you can pay nationwide to take out a $2,000 policy for a trip that if it gets canceled for any reason that you can recoup the money of hotels and plane travel and things, tickets that you'd bought, so forth. And say only 3 out of 5,000 people end up using this trip insurance. So what I want you to do is figure out the expected value. And again, it kind of depends on whose perspective. So I want you to figure out the perspective of the insurance company. So what is the expected value that they're going to have from this policy? So go ahead and try to figure it out and pause your computer right here, and then we'll come back and talk about it. Okay, all right, so let's look at this problem. So I'm going to make my little chart. So first of all, let's look at the probability. Only 3 out of 5,000 people are going to end up using it, so that's the probability that someone's going to end up using it. And remember, we're doing this from their perspective. And so, okay, so say somebody actually has to use it from the insurance company perspective, what happens? They lose $2,000, okay, because they're the ones that's going to be paying out that loss, okay? Now, the other possibility is, you know, that they won't use it, but we're just focusing on the perspective of the insurance company, them, like, kind of what their net worth is, like, how much on average are they going to make on this thing? So, they know sometimes they're going to lose money because people are going to use it. Now, what about income? Well, the people that are using it had to have paid the fee, because if you don't pay the fee, you don't have the insurance, and therefore you can't use it. So we know that there is a 100% probability that these people have paid the fee. And again, because we're going from the insurance company's perspective, this is positive money, because everybody who has this policy paid $50. So there's a 100% probability that the person paid the $50, but this is a probability that that person is going to actually need it, and the insurance company is going to lose some money here. So notice how you typically have some positive money coming in and negative money coming in. So expected value is probability 1 times value 1, probability 2, value 2, and then keep going, however big your chart is. So my probability that they actually use it is this. And if they use it, the insurance company is going to lose $2,000. But there's a 100% probability that they're going to gain $50 from that person, or from every person that pays this policy. So on my calculator, I'm going to go ahead and type this in. And then what plus... Oh, something's not right. I hope so if you put a negative in there. All right, so 3 over, 5,000. And then take that times a negative 2,000. Times negative 2,000. All right, and then add in that 50 times 1. All right, so I got 48.8. Now, again, remember, this is going to be money here. So, because my label on these are dollars, okay? So, this is my expected value. So, what does that mean? Again, people are going to take out this insurance policy hundreds of thousands of times, different people. And on average, since this is positive, that means the insurance company is making this much money per time period. So if the insurance company sells this for $50, are they sometimes going to lose the $2,000? Yeah, that's why people take out insurance. Sometimes people are going to need it. But on average, most people are not going to need it, and so, but they're still going to pay for it. And so on average, the insurance company is going to make $48.80. And again, that's how insurance companies work. That's, you know, they have a chance at a loss, and they have to figure out, actuaries have to figure out how much money should they charge based on the risk to decide what they're going to do here. Trip insurance depends on how expensive the trip is, if I'm going to take it out. With my mom and dad aging, when my dad was aging, I took out trip insurance a lot for DMAC travel. I did have to use it one time. My dad did pass away when I was at a conference, and I had to fly back and so forth. So that's one time I used it. Other times I've taken it out, I've never had to use it. So it just kind of, it's one of those things, it's just insurance. You don't know if you're going to need it or not, and so you just have to kind of decide. All right, I'm going to pause there. Oh, one thing to note is that if this was from your perspective, okay, so if we change this from the insurance perspective to your perspective, then suddenly you would be getting $2,000, but you would have spent $50. And so on average, you would lose $48.80, okay, if we're looking at it from your perspective. So you kind of have to know whose perspective you're looking at. All right, we'll try another one here. I'm going to pause and get it set up for you, and then we'll go through that too. Okay, so in this problem, we're looking for gold. If we try side A, it's a 20% chance that we actually find it. If we do, we profit $100 million. If we don't, we lose 10 million in the expenses. And site B, 10% chance, and we would profit 200 million, and if not, we would lose 18 million. So what I want you to decide is, should we go with site A or should we go with site B? And expected value is a really good thing to use because it helps you know on average what's going to happen in these scenarios. So do the expected value for A, do the expected value for B, and then tell me which site you think we should go look for gold at. Okay, so again, hopefully you tried this on your own because just watching me isn't going to really help you a whole lot. So try it on your own and then see how we do here. All right, so we need two charts because we have two scenarios here. We have a 20% chance that we find it. So we get gold, and then this is no, we do not. So again, if you have 20% chance that you find it, there must be an 80% chance that you don't find it. So what happens if we find it? Well, we profit 100 million. I'm just going to use 100. So my units I have to remember are in millions. All right. And then if not, I lose. So again, you see there's a negative value in there because it's not all win-win situation here. There's a negative value that could happen. Let's see down here, kind of similar. I have a 10% chance. And so then I have a 90% chance of not. So this is I find gold. This is I do not. Now, notice a huge return here, 200 million, and I could lose 18 million. All right, so if I do my formulas for both of these, and I got to kind of look where I have space. All right, so let's do the formula for this one. We have probability times value plus probability times value, and again, there should be a negative in there. So I'm going to type this in my calculator, times 100. Plus 0.8 times, what is it, negative 10. So this one is 12 million. Okay, and then let's look like this. So again, you're multiplying those. It's a weighted situation here. Plus, what, 0.9, and then negative 18. All right, so I'm going to take 0.10 times 200 plus 0.9 times what, negative 18. So this one's 3.8 million. So even though the payoff on this one is really high, the probability is pretty low. And so on average, if I drill, I guess I'm not really drilling, if I'm digging for gold at different sites, site A would be a better choice because I can make a lot more money that way. So choosing site B, I'd still on average make money, but I would lose money 90% of the time, and eventually that would add up to kind of compensate for that nice amount. So I'd still, it's better to go with this one, even though it's a lower payout of 100 million, I have a higher probability, and then if I don't find gold, my expenses are less as well. So you can kind of tell on average which one would be a better deal, and in this case, going with site A would be better money-wise.